Now that we have two examples of simple smart contracts in Plutus, let's interact with them. So this is now the off-chain side of things. And the easiest way to do that, although it's a very manual way, so it's sometimes very tedious, is to use the Cardano CLI. So both on Demeter and in the local setup, the Cardano CLI is already included. However, in order to use it in the local setup, you first need to start a node, which is also included in the dev container. You don't have to do that on Demeter. There it is automatically started for you. I'm in the local setup now, so there's a command start node, and that will actually start a Cardano node, but on the preview testnet. Of course, in this course, we don't want to spend any real money. And we pick the preview testnet, not the pre-production testnet, because it's fastest to synchronize. So when you start the node for the first time, you won't have to wait too long for it to synchronize. Let me open another terminal here. We also provided a couple of scripts. There's some at the top level of the repo that are more general in nature, and then also some here in the code folder for week 2. And one of the scripts is query tip. So that calls the Cardano CLI with the query tip command. And we specify on which network we are. So I said it's the preview network, and that has testnet magic 2. The pre-prod network has testnet magic 1. So let's execute that. And we see we are synced to 16.3%. So it will still take a while until we are at 100%, but it's not too bad. And it's much faster than with the pre-production network or, of course, mainnet. While we are waiting for the node to sync, we can already make some preparations. So one of the scripts here is create key pair that expects one argument, something like Alice or Bob, and then it will create 3 files, one for the public key, one for the private key, and one for the address. So the 2 relevant Cardano CLI commands are here. So address keygen, and as arguments the name of the file for the public key and the name of the file for the private key. And then address build to take the public key and create an address on the network. So I would call that like this, for example, with Alice. However, in my case, that already exists. In preparation for this lecture, I already did that. So I already created 2 pairs of public-private keys, Alice and Bob. So we can look at that. Here's the Cardano address, here's the public key, and the same for Bob. There's another useful script, query address. That's just Cardano CLI query UTXO with the address argument. So the address must be an argument to the script, again, for this testnet. So we can check how many funds Alice and Bob already have. So this expects the actual address, and seeing as I have that address in a file, do it like that. So there's nothing, but I think that's because the node is still not synchronized. So we need some more patience. Of course, when you freshly create these key pairs, there won't be any funds there. But you have the address now, so you can easily send some test ADA from a wallet to those addresses. Alternatively, you can also use the testnet faucet directly. So for example, if we want to use the faucet to fund Alice, then we can just copy the address, search for the faucet, follow the first link we find, pick the right network. So this is already correct. Preview, paste the address, prove that we are human, and click request funds. And then in about 20 seconds or so, Alice should be funded. You can't do the same for Bob because I think you can only use the faucet once every 24 hours. Either you need to use the Cardano CLI to send some money to Bob, or probably the better way is to, instead of using the faucet to fund Alice or Bob directly, instead use a wallet, then use the faucet to get test ADA to the wallet and then send from the wallet to Alice and Bob. So I use Eternal and Nami, but you could, for example, also use Yoroi. While I'm waiting for the node to synchronize, let's look at scripts. So first, make gift. So that is for sending some funds to the gift smart contract that we defined. So the script takes two arguments, the name of the sender, so in our case, Alice or Bob, and then a TX in. So some UTXO in Alice's wallet that they can use to pay for the transaction and pay for whatever gift she wants to deposit. So first, we need the script address. Remember, we saved the serialized script to this repository that was in the assets folder. Here, this gift Plutus, but that's the whole script. We need an address, and there is a handy Cardano CLI command for that. It's Cardano CLI address build, and you can give it a script file. So in our case, this gift.plutus, and must specify the network and a file where the resulting address should be written. Once we have that, we can build our transaction, and there are two ways to do that with the Cardano CLI. There's a transaction build raw command where you have more control, but you must take care of much more things manually, and transaction build, which is higher level. So I'm using transaction build here and specify the network again. Now I must specify the inputs of the transaction. Remember, transaction has inputs and outputs. So that is the parameter I specified in the command line as the second argument. And then output. So I want to send to the script address that I find in this file. That was the first step to write this file. And just completely arbitrarily, I send 3 ADA. So this output of the transaction will send 3 ADA to the script address, to the gift script address. Because it's a script address, we must attach a datum, but it doesn't matter which datum. So in our case, datum and redeemer were both completely ignored. So it must be any datum. And the simplest datum you can think of is the one that corresponds to the Haskell unit value. And I'll show you later how you can do that for more complicated values. But for now, there is a file also in the assets folder here, unit.json. So this is JSON representation of a built-in data value that corresponds to the Haskell unit value. So there is a utility to do that automatically. So you don't have to write this JSON by hand. After we say how much funds we want to send where, we must specify the datum. And as I explained, there are 3 ways to do that. Attach just a hash of the datum to the output. Second way is to attach the hash of the datum to the output and the datum itself to the transaction. And the third way, the one I'm using here, is to attach the datum directly to the output, and that's called inline datum. So with this dxout inline datum file, I can specify a JSON file that contains the datum. So I pick this unit.json that I just showed you. So of course, in this case, I only specify one input, one output, but you can have many inputs and or many outputs. Then I must give a change address. So all the funds contained in this input that are not needed for transaction fees and for payment of these 3 ADA must go somewhere. And I can specify where here. So I say it should go back to the owner, the one that's sending this transaction. And finally, I specify an output file where the transaction body that gets generated by this command is written to. Once this executes, I have a transaction body, but this transaction still needs to be signed because we are spending something that belongs to the sender. So the sender must actually sign the transaction. So this we do with the Cardano CLI transaction sign command, and it takes the file where the transaction body is and the file where the private key is. And again, testnet magic and an out file. So this file will now contain the signed transaction. And finally, I use the transaction submit command to submit the signed transaction. And there I must specify where to find it. And if all goes well, then this will be submitted and I can use the transaction txid command, give it the transaction file and get the transaction hash. And then I can use the hash to actually use a blockchain explorer, for example, Cardano scan, to look at the transaction. So that's the one half. So executing this should allow us to lock 3 ADA at the smart contract address. And now if somebody else, or also the same person, wants to spend that UTXO, collect the gift, there's another script here that takes 3 parameters. Again, a name and the actual input we want to consume, so the gift we want to collect. In this case, we don't need an input to pay for the transaction because we can pay for the transaction from the collected gift. And we also need collateral. So what is collateral? I mentioned before that validation on Cardano proceeds in 2 steps. So the first step is anything that can be checked without actually executing smart contracts. So for example, it's things like checking that the inputs are all still there. I mean, I could specify an input in a transaction, but then another transaction spends that input already. In that case, the transaction would be invalid and this validation failure would be found in the first phase. And once all these things have checked, the smart contracts are executed if smart contracts are involved in this transaction. And that is a costly process, relatively costly, because actually code has to be executed by the node and not just by one node, by every node that validates this transaction. So the idea is that you can do that locally. So before you ever submit a transaction to the actual network, the local node you submit it to will run validation and execute your script. So if something is wrong, if the script fails, then the transaction won't be submitted in the first place. But in theory, you could circumvent that. And in that case, create work for a lot of nodes. And in order to pay for that, this collateral is used. So you can specify some UTXO that you own as collateral, and the collateral must have a certain magnitude. Normally 5 ADA are more than enough. And if all goes well and the scripts validate, then nothing happens. But if the script fails, one of the scripts fail, then your collateral is forfeit. Again, this should never happen in practice. If something is wrong, if you don't have the right to spend a given script UTXO and the validator results in an error, then the node you are submitting this transaction to will already detect that and just won't submit the transaction to the network. And you don't have to pay anything. But if you somehow manage to circumvent that maliciously, then you could lose the collateral. Also, we need the protocol parameters because this transaction involves smart contract execution, because in order to spend the gift UTXO, the validator that we defined and compiled needs to be executed. And in order to calculate the costs for that and calculate the transaction fees, we need the protocol parameters that specify how expensive certain operations of a smart contract are. So for that, in order to get them, we have the Cardano CLI query protocol parameters. So we can specify a file where those are written to. And then later in the transaction build, we have to specify this protocol parameter. So we didn't need to do that in the first transaction because the first transaction didn't need to execute a smart contract for validation. We were just sending something to a smart contract. Validation and execution of scripts only becomes relevant when you try to spend such a UTXO. Now to actually build the transaction. So we have the input, the gift, the script input here. First, we give its reference. That was one of the arguments. Now we actually need to include the script. After the Vasil hard fork, we have an alternative where we don't have to include the script in the transaction. That's the mechanism of so-called reference scripts, but we'll get to that in a future lecture. So you can directly include the script. It's important to note that the first transaction we constructed doesn't need to do that. So if you send something to a smart contract, to a script address, you really just need the address. You don't need the script itself. Because in order to validate that transaction, the script doesn't need to be executed. Validation only comes into play when you try to spend from a script output, not when you create one. Anybody can always send anything anywhere. So there is no validation happening, no script is executed when you send arbitrary stuff to a smart contract. Validation happens, script execution happens when you try to spend a UTXO at a script address. So we are doing that now. We want to collect the gift. So we want to spend that gift UTXO. So we do have to include the script. So this is what this line does. And then we need to specify datum and redeemer. Normally, in these three cases, in the first two, if the UTXO was created with the datum hash, then we would, in the consuming transaction, the one we are constructing now, need to include the datum. But we chose the third option to use inline datums. In that case, it's enough to just say tx inline datum present. So we don't have to include the datum in this transaction. But we do need a redeemer. But because of the way we wrote our script, the redeemer doesn't matter. We just need one. So we can again use this unit.json, the same we used for the datum. Then the collateral we just discussed, again a change address, the protocol parameters we discussed, and an out file. And the rest of the script is the same as before. So we need to sign and we need to submit. Now the node has synchronized and we can actually try to do these steps. So first let's check what Alice owns at the moment. And we see she has two UTXOs sitting at her address. One 16.8 ADA and one, I think, 10,000 ADA. That's what we just got from the faucet when I demonstrated the faucet. So let's recall, in order to make the gift, what parameters do we need? We need the name Alice and a transaction input from which the cost for the transaction will be paid. So the transaction fees and the 3 ADA that we want to deposit in the contract. So it doesn't matter. We can take any of these. Let's take this one. So I can say code. So this is the normal notation that's used to specify TX out refs. So it's a combination of the transaction hash, that produce this UTXO, and because a transaction can have several outputs, we also need the index of the output. So this UTXO here was produced by a transaction with this hash and index 1, so it was the second output, and this here was produced by this transaction and index 0, so it was the first output of that one. And the way to write that in one string is normally to separate the two with the hash. So that's how the Cardano CLI does it. Let's try this. We don't get any errors, so that's promising. And if all goes well, this is the transaction ID. And here's a link to look at it in the Explorer. We probably have to wait a couple of seconds until the transaction is actually incorporated into a block and on the blockchain. So on average, that takes 20 seconds because on average, there's one block every 20 seconds on Cardano. Okay, it's already there. So we have transaction with this hash. Here's a summary. So Alice spent 3.16 ADA. So the 3 ADA that she deposited in the smart contract and the 0.16 ADA are transaction fees. And this is the contract address, and that received exactly 3 ADA. You can also see a bit more detail. So we see that Alice used these 10,000 ADA as an input, and she got 9,996.83 ADA in change. And this is what went to the smart contract. And here we also see that it is indeed a smart contract address. And here, this is for the datum. So we see the datum hash, and we also see the datum itself, so we can inspect that. And this is actually the same JSON that we saw before that corresponds to the unit value in Haskell. So now let's try for Bob to collect this gift. Let's first check Bob's UTXOs. So Bob also has two UTXOs, one for 2.8 ADA and one for 10 ADA. So what do we need to specify in the collect script? We need the name Bob, then the collateral, so that can be any of these two, and the input we actually want to consume, the gift. So we need to find out what to use there. So we can check all the UTXOs at the gift address and then pick one. And there are surprisingly many. So a lot of people, probably my colleagues in preparation for the lectures, tried this out. So there are loads of uncollected gifts, and we can pick any of those. However, because of the way we wrote the script, we need to pick one with an inline datum. For example, the very first one, there is a gift over 10 ADA there. So that's not the one that Alice just sent, but it doesn't matter. We can collect any of these. But for example, this one we wouldn't be able to pick up. That doesn't contain any datum. Actually, such UTXOs are unspendable. So you must never send value to a script address, to a Plutus script address, without including a datum. It's impossible to spend such a UTXO again. And then we also see this, for example, does have a datum, but it's not an inline datum. So it just has the hash. So we could collect that, but not with the script we wrote, because we wrote the script for inline datums. And we see there are others. So this, for example, could be the one we just created. Yes, I think this was the transaction hash. But it doesn't matter. We can, of course, be greedy and try to pick the biggest one that has an inline datum. Something, what's this? That's a lot. That's 100 ADA. So let's go for this one that does have an inline datum. But the first parameter we need is the collateral. So let's go back here. So we can pick any of those two. Let's take this one. It was index 0. And now a nice big gift. I think this one was the 100 ADA. That's also index 0. In this time we were too fast, so the transaction isn't there yet. So let's refresh the page. And there's the transaction. And we see that Bob indeed received almost 100 ADA. So we were able to collect the gift and we had to pay some fees, but the rest, 99.8 ADA, are now with Bob. We can actually make sure. You see the two previous UTXOs are still there. And we now have this additional one on 99.8 ADA. And as you see, there are plenty of gifts still at this address. So if you like, you can, of course, try to grab one of those.